As exciting as the rocket itself is, it's the payload that actually does the science while the rocket is in flight. Let's start by asking a simple question. What does the payload do? The payload we have designed has four main functions: to know where the rocket is in 3D space at all times, to maintain communication with the ground station, to get data from the science instrumentation, and to write that data to an SD card for safekeeping. Let's start by looking at the various parts of the payload and how those parts work together to help the payload achieve its goals. Let's start with the brains behind the operation, the Arduino microcontroller board. This is the central device of the payload and controls all the payload's other devices. We picked the Arduino over other microcontroller boards because it's cheap, easy to program, and already has a large community that supports and uses the device. When we write the code that makes the payload function, this is the device that we load that code to. Next, we have our GPS chip. This works exactly the same way as the GPS that might be in your car or on your cell phone, giving us our longitude and latitude. The only difference is we also record the altitude value, since so much of our motion is vertical. When we're finished, we get a depiction of the rocket's path that we can display in software, like Google Earth. Of course, we'd never be able to use the data from our rocket launch if it wasn't stored somewhere, and that's where this SD card comes into play. This is the same kind of storage device you might find on your phone or in your laptop. It's quick, cheap, and gives us plenty of room to store lots and lots of data. We write the data in real time to a simple text file, and when we're finished, we get something that looks like this. Looking at the data in this raw form probably isn't very exciting, but we'll be providing you with the tools you need to process this data and get something interesting. Getting your data from the SD card after you recover the rocket is great, but what's even better is getting the data in real time as the rocket's in flight, and that's where our Wi-Fi chip comes in. We use the exact same kind of Wi-Fi technology that you might use to connect your phone or laptop to the internet, though we have some specialized antennas to extend the range of such devices. Our software mirrors the exact same data to both the SD card and the Wi-Fi chip, so we have backups of our data in case the rocket is destroyed on impact or loses connectivity during the flight. Another advantage to having a Wi-Fi chip on board is that we can verify that our instrumentation is working while the rocket's on the pad, or we can't manually check it. Of course, all these devices need to be physically connected in order for the payload to function, and that's where this printed circuit board comes into play. This is the only part of the payload that wasn't off the shelf. It needed to be custom designed and fabricated. As you can see, the pieces of the payload snap together, and this eliminates the need for us to solder. This is also the device that physically holds the entire payload together, so it's a very important piece. Everything we've shown you so far is part of the base payload that every team will fly. Of course, it wouldn't be very exciting if every team flew the exact same payload, and that's why each payload will include a science instrument selected by the team and their instructors. In this particular instance, we're flying a pressure and temperature sensor, but your team can select from any of myriad devices available from various electronics websites, or you may even design your own from scratch. When it comes to the types of payloads you can fly in this program, the sky isn't only the limit, it's also the target.